Dear students, in this section we are going to discuss one very important concept of the mechanics, that is conservation of linear momentum for system of particles. According to this principle, the total linear momentum of a system of particles is conserved if no net external force is acting on the system. Okay? And this statement, that is conservation of linear momentum of system of particle, is independent of nature of the forces acting between the particles of the system. That means this statement is independent of internal forces acting between the particles of the system. And these internal forces may be conservative or non-conservative. That means we can say the linear momentum is conserved for isolated system regardless the nature of the internal forces, even if forces are non-conservative. And this conservation of linear momentum principle is universal in nature. That means it is applied to both macroscopic and microscopic system. That means we can apply conservation of linear momentum for Earth and Sun system, and even we can apply this conservation of linear momentum principle for atomic or nuclear physics also, where classical mechanics fails. Okay, and this is more generally applicable principle in comparison to the law of conservation of mechanical energy, because internal forces of the system are often non-conservative in nature, and in case of the non-conservative forces, mechanical energy cannot be conserved, but we can conserve the linear momentum for the system. And we can apply conservation of linear momentum for isolated system. That means the linear momentum for isolated system is conserved, but linear momentum of a particle, one particle within the isolated system may not be necessary conserved, because this particle can be interacted by the other particles of the system. Okay, so let us learn the application of this principle now, and here we are going to take few selected illustrations, and through these selected illustration we are going to learn this principle. So let us move to illustration number 1. In this illustration it is given a body of mass 5m. Mass is given in term of small m. It explode at rest, break into the 3 parts. If 2 parts having the equal masses fly up perpendicular to each other with the velocity of 18 meter per second. Then calculate the velocity of the third part, which has mass 3 times the mass of each part. Okay, so this is the problem. Now let us analyze the situation. Initially it is given the body is at rest. Body is at rest, that means initial linear momentum of the body is 0. Now explosion occur, and after explosion body break into 3 parts, right? There is no external force acting on the body. That means the linear momentum of the system just before explosion and just after explosion should be conserved, right? And we are given the total mass of the body is 3m. Let the mass of 2 part is m, and it is given the mass of third part is 3 times the mass of each part. So mass of the third part can be taken as 3m. So let us make the diagram of the situation. This is the body, right? Initially it is at rest. Now it explode into 3 parts, and 2 parts start moving perpendicular to each other, having the equal mass and equal velocity magnitude. This is the part number 1. It is moving along the x direction, and this is the part number 2. Suppose it is also having the same velocity magnitude, and it start moving along the y direction. The magnitude of the linear momentum for both particles is same. Okay, and let us decide where the third particle will go. Let third particle move in this direction. The mass of third particle is 3m, and velocity of the third part is v. Okay, and initially we know this body is at rest, that is the initial linear momentum just before explosion is equal to 0. So, here we can write P initial equal to 0, okay, and P final. Now, come to the final linear momentum. Final linear momentum, we are assigning the linear momentum just after explosion. So, let us write linear momentum just after explosion as P final. P final should be equal to P1 vector first, second P2 vector say, and this is P3 vector for the third part. So, we can write P1 vector plus P2 vector plus P3 vector. We know the first part, say, which is moving along the x direction, it is having the linear momentum magnitude m multiplied by v1. So, unit vector for linear momentum should be I cap. For this which is moving along the y direction, the magnitude of the linear momentum is mv1 and the unit vector in this direction is j cap, and we don't know in which direction this particle is moving. So, let us take this as unknown. So, let us write mv1 I cap plus mv1 j cap plus p3 vector, okay, p3 vector for the unknown one. As we know, linear momentum initially, this body is having 0 linear momentum. That means this linear momentum P initial should be equal to the P final. So, this value should be equated to 0, right. From this equation, we can write P3 equal to minus mv1 I cap plus mv1 j cap, okay. Now, we can rearrange this equation. We can write this value as m3mv vector equal to this one. Now, we can write v vector, that is the velocity of the third part, equal to minus 1 by 3 v1 I cap plus v1 j cap, right. M and m will get cancelled. So, this is the velocity, and here we are given the magnitude of the velocity of these two parts is 18 meter per second. So, here if we substitute 18 meter per second, 18 meter per second, so this value, that the velocity will become 6 I cap minus 6 I cap minus 6 j cap meter per second. So, this give the velocity for the third part, and from this expression we can decide this velocity direction is equally inclined with the x axis or y axis, that is negative x direction and y direction. So, this angle should be equal to 45 degree, right, 45 degree, and it is in the third quadrant, and magnitude of the velocity can be given as 6 root 2 meter per second. If it is 45 degree, so this angle, that is the angle made by the third part with the first direction of the motion of the first part, is 135 degree. So, now we can say the third part, that is this part, will move at angle 135 degree from any of the ball, right, or any of the part. Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.